First, good morning, everyone. Welcome to this week's CCB seminar. This is the last talk of this series for this year. And it really is a great pleasure to introduce today's speaker, who is Nico Matinsoglu, who was my colleague at the University of Manchester back in about 10 years ago or so. He's now an independent contractor who works in the semantic web area with semantic web technologies, graph technologies, knowledge engineering, and so on. Back in the day at Manchester, we had the same PhD supervisors, and we worked together on a number of projects, namely this OWL Reasoner Evaluation project and competition, where we organized a workshop and designed a competition that would pit together a bunch of reasoners, ontology reasoner systems, and evaluate their performance and correctness with respect to their entailments. And after that, Nico joined the European Bioinformatics Institute, EBI, where he was working at the Samples, Phenotypes, and Ontologies group. And there he participated quite a lot in projects like the Monarch Initiative. He worked on things like the human phenotype ontology, the Monarch disease ontology, Mondo. More recently, he's also been working on the environmental conditions, treatments, and exposures ontology, ECTO. And also things like software packages and in particular the ontology development kit, which provides this set of workflows and packages that can be automatically executed so that you can develop ontologies from the get-go far more easily. That can all be done from a single Docker image, and a bunch of other sort of ontology-related tools that have been used quite heavily in the biomedical ontology community and so on. And today, Nico's going to be talking to us about SSSOM, which is the standard format for writing and for sharing these mappings between ontologies. And I'm really looking forward to this talk and to welcoming Nico here in this group and to hear from him a little bit more. So thank you, Nico, for joining us, and please take it away.
Thank you very much, Rafa, for this very amazing introduction, and nice to meet you all. Yeah, I'm going to jump right into it. So I'm going to introduce this standard today, but before we get there, I'm going to also motivate a little bit, maybe with a bit detailed, why such a standardization is actually worth it from our perspective. So to set a little bit the scene. So in a normal kind of scenario, when we have a bunch of data generating organizations, in the beginning, data generating organizations, they may generate their data in whatever form they are generating it in. They have their own data models, they use their own terminologies or not, and produce what we in like data integration would refer to as more or less data silos. But what happens after a while usually is that these organizations realize, okay, we need somehow to link our data with data from other organizations. So let's imagine here a scenario where these data providers somehow collected data that was related to anatomy. So, for example, gene expression data or some phenotype databases or something like that. And they realize, okay, we need to integrate this stuff with other groups. So what usually happens is, because in like a globalized space, we don't really have something like a top-down sort of approach for standardization. It's just that little kind of what we refer here to as semantic spaces emerge of groups that say, let's adopt this standard, or let's adopt this other standard. And here, for example, these two organizations, either together or separately, decided that they would use a standard for representing anatomy, which is called Uberon, the Uberon anatomy ontology. So, for example, when they were making reference to an entity like blood vessel or something like that, they would use a controlled term from this ontology, the Uberon ontology, by referring to this concept by the identifier of Uberon, for example. Yeah, so the problem is, because it was this kind of process is decentralized, you also have at the other corner of the world another organization that will say, okay, that also understands the need for standardization, and will adopt the foundational model of anatomy, for example, and implements that in their workflows. And yet another organization decides, either because they don't know about FMA or Uberon, or because they think that they are not quite suitable for the use case, to develop their own controlled vocabulary to refer to their data. So now the problem is, not only is it exceedingly hard to adopt the standard. So the problem is that once you have adopted it, especially in our biomedical domain, you have the problem of that these standards are living standards, where you have to, especially when you have databases that are focused on curation, you have to be able to constantly add new terms, change things in there. And what happens is when many more organizations start being interested adopting a particular standard, is that also this process becomes more and more complex. So it may be that there's disagreement between major players in a standard about what's the coverage of this standard. Here, for example, the Human Cell Atlas wants to add 100 terms reflecting certain part of anatomy, which, let's say, Monarch Initiative says is completely out of scope for the standard. Or there's some disagreement about the internal representation of the anatomy. So the point here is this can be very, very costly. What this means is that in the end, so we will stick with these kinds of semantic spaces. And if, let's say, the semantic web people like me and many of my kind of fellow colleagues, they will come in and say, well, you've all adopted a standard, but the ideal would be, why don't you all refer to the same standard? But after going through this massive process where you've bent over backwards to adopting one standard, it's very unlikely actually that you will go through this process again to go to a scenario like this, where everyone says, let's adopt the great Uberon ontology, which works for everyone. So we basically are at the state where most of the time these spaces are established. We have different gene identifier schemes. They won't go away. We have different disease ontologies and terminologies. They won't go away, and the same for anatomical ontologies. All right. So what do we, so we've seen, okay, we are adopting various different standards. So why do we care? So we care because we need to be able to do analytics across semantic spaces. So here, this is just a simple example where we wanted to do something that sounds trivial. We wanted to just count how many rare diseases are there. So this is it sounds like just running a count query in a database. But the problem is that the coverage of these various different standards, so these are just 5, and the situation would be aggravated if you would add a few more in this mix. You would see that there's only a handful of codes that are actually covered by all 5 of these relevant vocabularies / ontologies / terminologies in the rare disease space. And there are quite a few cases where there's just one of these vocabularies that actually covers a huge number of diseases. So just in order to do something like a count, you need to be able to put these things somehow all together. And if you want to go even further than just simple counting, to build proper analytics engines which allow you to discover patients with similar phenotypic profiles and do some other kind of interesting advanced analyses, then what you need is you need to integrate all of this stuff in some kind of a common structure. Like what we usually do is we integrate all of this in a knowledge graph structure. And what thing in particular, what you want when you build such a knowledge graph is, if you have different databases referring to Friedreich's ataxia, you want to make sure that somehow there is one blob in your knowledge graph that represents Friedreich's ataxia, so that you can integrate and integrate all the annotations around this particular disease from the various different sources. All right, so since we can't put all of these ones together, we can't go and force everyone to use the same ontology, the same standard, the same data standard, whatever it is. What we need to do is we need to map across these spaces. So there's at least realistically from our experience, no world in which the unifying ontology will actually work. So there will be always some need to map across these different spaces so that data that is generated can be analyzed in conjunction with each other, so together. Right, so now before we move on, let's just establish a little bit the word mapping. So there was a surprising amount of variation when we started working together about what people understood to be a mapping. So I'm not going to talk to you about all the 60 different definitions for what a mapping is that we have had, that we've discussed about, but there's kind of two rough big groups of what we mean, of what people talk about when they talk about mappings, which is entity mapping, so determining and documenting the correspondence of an entity in one semantic space to another. So one HGNC identifier to one interest gene identifier, one disease ontology term to one NCIT term. So this is the one kind of space, and the other space is this whole business of schema mapping. So here we want to determine and document the translation rules for converting an entity from one semantic space, in particular one relational database or something like that, into another. Now this is a very, very much more complex business that obviously requires a lot of thought and a lot of love from us as a, let's say, standardization community, but this is not what we are talking about today. So we are really focused here on the business of entity mappings. All right, so let's talk about entity mappings then. So let's imagine two databases, one database referring talk about rare disease. So in this case here we have one, let's say, relational database that refer to Friedreich's ataxia in a data records using the string Friedreich's ataxia, and another database that refers to the same concept using an OMOP identifier 441554. So the essence of what this is that these entities that we are talking about, these entities are somehow, they are symbols. So symbols like codes in a terminology, or classes in an ontology, or enums in a data model, or just even these strings like this one here, that are intended to refer to a real world thing, or the same real world thing. So in this case, the disease Friedreich's ataxia. So what we mean when we say we map this to this Friedreich's ataxia string here to this OMOP identifier is we kind of mean they refer to the same real world thing. And there are different kinds of mappings that we want to distinguish here. There are mappings like mappings between strings to identifiers. Here adenofibroma to a controlled term in the Mondo disease ontology as an example. Sometimes these are referred to as synonyms. There are many different disciplines dealing with this kind of stuff, like entity recognition, entity linking, that you or many of you are maybe very familiar with. Then we have identifier to identifier mapping. So here is an example from the experimental factor ontology, mapping an identifier that refers again to adenofibroma to the Mondo ID, corresponding Mondo ID. And then complex mappings as a third category, where we have a term like, for example, in this case, cheese sandwich that refers to a compound or what we sometimes call post-coordinated expression of terms of other terms. So for example, in this case, sandwich and cheese. So we have these three kind of categories. The design of SSSOM, like in its original iteration, is focused on these type 2, but we can, if you're interested in, talk about type 1 and type 3 maybe in the discussion afterwards. All right, so what's the problem? When you look at like mappings out there, so they exist in various forms. Most of the mappings that are, for example, published as part of scientific literature or as part of scientific databases out there are essentially 2-column spreadsheets, essentially. So this here is an example from like a really awesome effort, which is OMOP, which integrates a lot of different clinical terminologies. And you can see one thing here. So basically you have a mapping from some ICD-10 codes. So the first row, we have amoebiasis maps to amoebic infection. So if you're, let's say, a clinician, and some clinician convinced me that this makes some sense, at least this mapping, this is all right. But if you look at the second example, you see refractory anemia with multilineage dysplasia is mapped to refractory anemia. You immediately see there's some information lost. However, we don't know in what way the information is lost at all. So we don't have the semantic precision that tells us, is this, for example, a broad match rather than an exact match? All of these are the same in the treated in the same way in OMOP. All right, so there are also more complex things like post-coordinated expression that map to multiple terms in the target ontologies. All of these are treated using the essentially same semantic relationship in the raw data were you to download it. And while you can find information about how to treat those in the kind of documentation pages somewhere, that is what you see when you download the, let's say, OMOP relationships table. That's the first thing you witness. So when just as a last clarification on semantic precision. So again, here this is a few more examples where with real cases where you want to map, for example, a GARD identifier, Fanconi anemia, to an OMIM identifier, which stands for Fanconi anemia B. Now, obviously, this is conceptually a narrow mapping rather than an exact mapping, and but not only that, you have also cases where you want to map, for example, a phenotype like an HP identifier, absent thumb, to Fanconi anemia A, or link even the FANC-A gene to the Fanconi anemia A. So while many of you and many of us would object to calling these things mappings, in reality, they are very often also produced as mapping files, and there are actually use cases where these are used for merging data sets with each other. Okay, so then the second problem is that mapping space is enormous. So if you have, imagine 6 different, so let's say 6 terminologies talking about diseases, that's very conservative. There are many more. Then you have 30 different ways that these can map to each other. So there are a huge number of combinations. And if you consider this for all the different kinds of entities out there, this is just in the hundreds of millions of mappings you would have to look at and you would have to produce. And many of the mappings that are already out there, they conflict when you try to combine them with each other as well. And even though like so one kind of attempt to order this a little bit is like the emergence of these hub and spoke solutions like UMLS or OMOP or Mondo or some others, where you have like a one central concept and then try to map all of the kind of different terminologies into the central, let's say, identifier scheme. Even these ones are proliferating now, and there's also the question, like, how do they relate to each other and how much coverage does each of these have? Secondly, it's extremely hard to do mappings. So we in one of our projects in Mondo, we have to deal with like this constantly, where we have to determine whether let's say a disease that represented by different terminologies, like in this case Zellweger, don't know how it's pronounced, sorry about that, syndrome in orphanet and NCRT and DO actually refer to the same thing. So while the label is the same, the definitions are entirely different, the synonyms are entirely different, and as you can see here, the classification in the ontology is also entirely different. So it takes a lot of expertise, including medical expertise, semantic expertise, to determine really, are these supposed to be the same thing or are they actually something different with the same name? And then, of course, good mappings are a moving target. With every release of a source vocabulary ontology, the mappings may change. So we have to deal with obsoletions, classes that just stop existing in a source vocabulary or ontology. We may have in a new release a better term to map to, and we need to know that and then change our mappings to this better term. And also conceptually, many of these mapping efforts out there are like iterative processes, which improve over time. So they start with a small coverage, for example, covering everything in an area like coronavirus, like COVID-19, and then expanding to other kinds of infectious diseases, and later covering all diseases, for example. And they are also iterative in the sense of quality. Maybe in the beginning you just publish a huge mapping that is just determined by lexical matching by some automated tool, but humans are going to interact with this, fix mappings, change them, and so on, and these mappings will improve over time. And different efforts require different levels of perfection in these mappings. So if you have a medical coder, there's no room for error, because an error in a medical in a clinical so terminology mapping can potentially lead to the death of a patient, while in something like predictive analytics, where you're using machine learning approaches and stuff like that, you are much more fault tolerant, and you can deal probably with a much higher level of noise in your mappings. So in summary,
cool.
Yeah,
question from the audience. So Ben Giori is asking about your view on curating direct mappings between two terms A and B, if it's possible to infer the same mapping indirectly via existing mappings like A, C, B.
Excellent, Ben. I have a slide exactly for that, which will come in a few seconds.
Okay, cool. Thanks.
Thank you. All right. So we know establishing the mappings requires expensive expertise, not just semantic and domain, but also data engineering for the poor people that need to figure out how all these like great and matching tools out there work and how to tune them. This is really difficult, hard work for those that have tried it. Then we have this big mapping space that needs to be covered. We have constant change. And also we have the problem that mappings are not really bad or good in some kind of objective way. They're just fit or unfit for some particular purpose. And fitness for purpose is something that's extremely difficult to communicate, to test, and to implement. So we believe we can do better. We can do better by sharing mappings to avoid creating the same mappings over and over again. We can enrich mappings with additional metadata to increase cross-purpose reusability and enable the combinations of mappings from different sources. So what we will discuss in a second regard to Ben's question. And we can build a more coordinated, decentralized effort of human curators, similar to what we've already achieved for ontologies, like in the context of the Obo Foundry, if you've heard of it. And so our hope is that society should not have to fund the incredible duplication of effort that we currently have. So I've seen in just like 2-3 years of working in this mapping space, a lot of different projects reiterating the same mapping over and over again and passing them to some poor curator. Please do this mapping between Mesh and EFO. Please do this mapping between Medra and SNOMED, and so on. You see this like happening constantly, and that is really something we need to avoid as a society. All right, with that, we start introducing the simple standard for sharing ontological mappings. So just a quick word about this picture. So this is like from some I don't know unfortunately how it's called in English, but it's from a story from 1001 Nights, let's say, where Alibaba is calling going to his secret cave and saying sesame or sesame actually open the door. This is like the code word, and we kind of like found this funny as like a way to depict because sesame and sesame sounds sort of simple, that this is kind of our way to unlock the huge amount of biomedical data that sits behind this door. So it's a bit a bit cheeky maybe and a bit overstated, but I think it's a good analogy that mappings is actually something really essential to combine and integrate all of this information that we have out there. All right, let's start talking about SSSOM for real then. So what is kind of the very basic anatomy of a semantic entity map? So for those of you who are more familiar with the kind of RDF way of thinking, the essence of a mapping is still sort of a triple. So you have a subject that is mapped to an object via a semantic mapping predicate. So the subject is referred to by an identifier. So in this case here, we have, for example, an EFO identifier. The object is again referred to by an identifier, which is the Mondo identifier. That we can also attach additional pieces of metadata to these. For example, we can add a label to both of them to make the mappings themselves more easily handleable, readable, reviewable by curators. And then we have the mapping predicate, which is very essential for this standard, which we typically draw from a set of standard already existing mapping vocabularies out there. So the most widely used one that we implement and we encourage to use is the SSSOM mapping relations. What this gives us is, and we will discuss it in a second, what this allows us to do, a more precise way to deal with mappings. But then, and that's kind of like the really important part in SSSOM, every mapping is attached to one or more justifications. So a justification, we will discuss also a bit more clearly, is something that says, that provides evidence for why this mapping holds true. So for example, here we have let's say a lexical matching as a justification that matched on a label in the subject to a synonym on the object on this and that date, reviewed by this and that person, using this and that tool with this and that level of confidence. And we will go a little bit more in this in a second. So what is exactly like a file, like a SSSOM file look like? So the original design of SSSOM was very, very focused on like simplicity of representation. So we chose a table format for the original and most frequently used and implemented serialization of the format. So you see here in the bottom, you have the different columns representing different metadata about the mappings, like the confidence values, the justification, the author who wrote it, and so on. And then you have this header part, which is a hash commented YAML file, basically, that is part of the actual file, which gives us a bit of information about the mapping set itself. So the identifier, some description, who made it, with what license is it published, and so on. So to use this kind of header is can be dealt with by normal tools like pandas, for example. Pandas knows that if you do pandas read table and comment equals hash, that it will ignore lines like that and can just read the table in. So we designed this in such a way that normal data science pipelines can deal with this format here. But it's also possible to export these and deal with them in other formats like JSON, RDF, obviously, and I think these are the main other ones. So now to the question of Ben before. So what exactly can we gain from introducing semantic mapping predicates, and can we use them to actually get more mappings from the ones that we already have? So let's imagine we have a mapping here from this OrphanNet ID, which is an exact match to this Mondo ID, which is a broad match to this ICD-10 identifier. So if we use a semantic mapping predicate, we can exploit the semantics of that semantic mapping predicate to do certain things with it. So for example, we can exploit symmetry of the SSSOM's exact match mapping predicate to do walkbacks. If orphanet, the orphanet code is an exact match to the Mondo code, then also the Mondo code is an exact match to the orphanet code. So that's a simple but nice thing that is not possible already with most of the mapping sets that exists out there, where the precision, so the mapping predicate, isn't actually explicitly mentioned in the mapping set. And we can exploit other characteristics, like, for example, inverse relationships, to do again walkbacks over relationships like broad match. So if the Mondo ID is a broad match to this ICD-10 identifiers, then the ICD-10 identifier is a narrow match to the Mondo ID. So the combination of these, so the ability to do walkbacks, already reduces this kind of n-squared mapping space by half, by allowing us to basically only curate in one direction and always know we can always go back. But then the really important thing is that we can actually exploit the mapping semantics to get to build mapping chains. So for example, we can exploit the fact that orphanet is exact match to Mondo, that is broad match to ICD-10, to simply jump straight from the orphanet code to the ICD-10 code by going over this mapping chain. So if you're from the OWL semantics word, this would be called a role chain, but yeah, let's call it mapping chain here. Okay, so this way you can really like drop the costs of curating this n-squared space massively. If these are reliable here, then this will allow us to really go make it much more feasible to cover more different semantic spaces. Okay, so now,
Nico, sorry to interrupt again. We have a question in the chat from Charlie Hoyt. So in slide 25, it looks like a justification includes both the evidence from an automated lexical mapping, but also the reviewer. So should these evidences go in the same justification or in separate ones? So,
all right, it's a great question, and that's the next slide. So I will tell you exactly, I will tell you what the purpose, like, why is there a reviewer here? And actually, I will tease this apart here in this slide. So if let's try it here. So basically, any mapping can have any number of justifications. So the justifications themselves, these are the things that we really attach most of the metadata to. So if you have, for example, the exact mapping between A and B, you may say that there is a justification for this mapping, which is a human manual curation effort where some author with this and that ORCID has determined that this is a good match with a confidence of 70%. And at the same time, we may have another mapping justification that comes from a lexical matching pipeline that says after a match of the RDFS label of the subject with the scores preferred label of the object, matching exactly the match string S, after the pre-processing of case normalization has been applied to the subject, we determine that this mapping holds true. Now, with the reviewer identifier, we don't actually make a law that you have to make a new justification for a review process, but you could. So there is a possibility to just add, let's say, a justification that says mapping review, where someone just looked at an existing justification without any more context, not looking for anything else, and just saying looks good, looks bad. So you can create a new justification for this, but you can also, in order to indicate that you have not reviewed the mapping, but you have actually taken a look at what the quality of the justification is, you can also attach the reviewer reference straight to the justification, just to be able to express the reviewer looked at the justification, not whether the mapping is good, but whether the justification looks okay. So that's how the reviewer ID comes about. But yeah, it's that I didn't even think that I didn't even want to raise this kind of confusion here in this talk, but good that you mentioned it. Is this okay as an answer, or will this result in an issue tracker item saying that this introduces too much complexity and we shouldn't do it?
No, I think this sounds okay. Maybe the end of the question was going to also get addressed later, but if you don't mind, I'll also read that out. So like more generally, the question was, when we've got multiple justifications, how are we going to aggregate or assemble them together and come up with some kind of like, yeah, aggregate confidence? Have you got slides on this, or?
I have no slides on this, but I can show some I could show some examples, actually, like some proper examples after the talk on the GitHub repository to explain this. If I forget it, remind me again in the end.
Will do. Thanks.
All right. Okay, so that's the big second component. Less relevant, but one of the kind of key design decisions we made for the format is to try and use as much controlled vocabulary as possible. So in particular, for representing things like the preprocessing, different preprocessing techniques, for the different matching processes, review processes, and so on that can be employed for justifying a particular mapping. We are building a bespoke standard vocabulary that can be easily extended, also independent of the SSSOM core standard. So we separated these two so that we can easier just add like 10, 15 justifications to this vocabulary without having to make a new release of the SSSOM standard. So there's a controlled vocabulary here, and just one word about the kind of conceptual, the idea of using entity reference. So in all of our standards, we kind of use this query syntax for referring to an entity. So when you see the SSSOM mapping tables, you see these kind of queries in there here representing entities, and in this sort of semantic web way of thinking, these unfold to your eyes that you should be able to look up on the web when you do so. So that's just another design principle that we have. All right, so now let's think one level further. So we have now, let's say we have a standard, nice. So what are we going to do here with a standard? So the kind of vision that we have behind all this design is to be able to build mapping comments that look a little bit similar to, if you're familiar with the way that we are managing vocabularies in GitHub version control and so on, where people come together that are interested in a particular space to map. So for example, here, this is an example where a group of people is collecting mappings that somehow relate to linking between mouse and humans. And this is here an example of where, let's say, an editor from MGI, they had a some contract or some project with Kids First, and they were asked to create a mapping of all COVID relevant phenotypes in the human phenotype ontology and map them to the mammalian phenotype ontology. And they just put a SSSOM file in the registered this year at this repository. And the cool thing is that if you're familiar with also these kind of these other workflows, like in the ontology workflows, is that if you use such a system, you can also use all of the kind of standard systems we have now for introducing quality control. Like you can test whether this mapping set, for example, is well formed, whether it conforms to the standard prior to merging it in, and all this kind of thing. And also we can use GitHub's amazing ability for collaborative work to facilitate discussions. So people can comment on the pull request and say, oh, this mapping doesn't make sense, or something like that. Or someone can say, this mapping, so there was an issue just a week ago where someone said this mapping is actually broken or wrong. And we can collect the information about wrong mappings here as well. And this kind of relates slightly to what Charlie was asking before. So if you are thinking about about reconciliation, so now these mapping comments in the first round, what they do is they will collect, let's say, different mapping sets from different places. Some of them will be automatically generated. Some of them will be curated in a ad hoc bad manner. Others will be high quality mapping. So what these mapping comments registries are supposed to also deliver is some way to automatically reconcile those different mappings into some, let's say, one standard output that comes out at the end, where like bad mappings are automatically weeded out from the set of all merged mappings. So we can talk about this in the Q&A later, but this is where I will leave it for now, and I can show it to you also how this works. So bigger picture, you have mapping commons. Mapping commons maintains a bunch of mapping sets. Mappings are part of mapping sets. And then we have kind of mapping servers, standard APIs out there that can link to mapping commons, index the mapping commons, and make mappings available for various use cases like data normalization or knowledge graph linking or whatever. So this is kind of like the wider idea that we have for these mapping commons, but this is so early, like I don't even want to talk about this part here, although we do some development here. It's very, very early to talk about concrete outcomes on this. There are some toolkits around for dealing with mappings, but I just want to re-emphasize that the point of providing a simple spreadsheet-based format was that you do not need specialized tooling to deal with them, in particular to read them. But if you are actually a provider of mapping sets, it does make sense to have a command line client that allows you to merge mapping sets, parse mapping sets from different formats like let's say other standards that exist, do validation and filtering and stuff like that. But in general, you can just use your normal pandas workflows here. And then we have some implementation in the ontology access kit, which implements some functionality for very basic lexical matching, which also exports the justifications as these mapping justifications as SSSOM. And we are building support for SSSOM mappings into the ontology development kit so that ontology developers themselves can more easily offer and distribute their mappings if they choose to curate their own mappings from their ontology to other standards as well. All right, so what are we trying to accomplish? We're trying to accomplish a shared provenance model that allows us to do cross-purpose reuse of mappings. Mappings are produced for different reasons. We want to enrich it with just enough metadata so that we are able to confidently reuse mappings that were produced for a different purpose than ours. We want to have a shared model for computable justifications and confidence to increase the trust in these mappings and enable automated conflict resolution and explainable mapping decisions. We want to have a shared model for semantic mapping predicates to allow these kinds of crosswalking mapping chaining that we've shown before. And we want to develop shared infrastructure for mapping integration and quality control and mapping delivery. All right, so this much for the main part of the talk. I just want to say, for those of you that are mapping providers or are building mapping sets, what do we do now? So we have developed like a simple 5-star system for mappings that has, let's say, 5 levels in which you could try to adopt one after the other, the first 2 of which do not even involve SSSOM as a standard. Because sometimes perfect is the enemy of the good enough, and we realize it's really, really difficult to get people to even publish their mapping, let alone standardize them in many, many cases. And yeah, so I want to really use this one moment here to talk to all of you to say, please lobby. If you have any people that you work with, anyone that are providing mappings, to publish these mappings under an open license, CC0, CC BY at max, under a public URL without any need for like authenticating and tokens and API registrations and whatnot. So something that makes it really easy to take these mappings, combine them in a mapping commons, and republish them as reconciled mappings in a larger effort. So Charlie, for example, has been building up this biomappings project, which includes SSSOM export. in it as well, and he's doing this like it's his like his heart and soul to get us all to publish the mappings in public CC licenses and make them easily available. That's it. So thank you very much. Just some quick acknowledgements. So much of the work on this standard was funded by Phenomics First and NIH NHGRI grant, by Monarch grant, also by NIH related to cross-species mappings, by a gift from Bosch to Lawrence Berkeley National Labs, and by a young faculty grant from DARPA to Ben. So there are lots of contributors, so thanks to all of them. And with that, I'm opening the floor for questions. Thank you very much.